Hello grade 11s, we are just starting our next chapter, which is about trigonometry and angles. So please make sure you have the notes in front of you and fill in the blanks as we go. So in geometry, an angle is formed by two rays with a common end point. So what that means is here we'd have a ray and here we'd have another ray and they meet at a common end point, forming an angle. Now in trig, angles are often interpreted as rotations of a ray. So now we're talking about the actual degrees associated with each angle. In this diagram, the initial arm is the starting position. So initial arm is the starting position, and the terminal arm is the end position. Terminal arm. And the angle, which we use the symbol theta, so it's like a little circle with a hat on top, is the degree of rotation between the two arms. So the angle is the degrees we're talking about. Now an angle in counterclockwise position, the angle is said to be positive. And if the angle is clockwise, then the angle is said to be negative. So let's say we're starting here with our initial arm on the x-axis. If I go in the counterclockwise direction, that would be a positive angle. But if I would go in the clockwise direction from that initial arm, that would be said to be a negative angle. So if you start on the x-axis and go up, it's positive. But if you start on the x-axis and go down, it's negative. Now we're going to talk about angles in standard position. Now this is a really important topic. On a Cartesian plane, you can create an angle by rotating a ray around the origin. So that's very important. It has to rotate around the origin. To be in standard position, the start has to be along the positive x-axis, so that's where the initial arm is. And the end, again, it has to rotate around the origin, is where the terminal arm lies. So to be in standard position, the vertex has to be at the origin and the initial arm has to be on the positive x-axis. Angles in standard form are always shown on what we call the Cartesian plane. The Cartesian plane has an x-axis and a y-axis that divides the plane into 4 quadrants. Now the quadrants are here as shown. We start with quadrant 1, quadrant 2, quadrant 3, and quadrant 4. These quadrants we always want to be written in Roman numerals. So that will be very important, so they're always written in Roman numerals. We also have a diagram here that shows how a standard position angle must be. So again, it has to start on the positive x-axis and it has to rotate around the origin. That's very important. So for example 1, we're going to sketch each of these angles in standard position and state the quadrant that the terminal arm lies. So state the quadrant that it ends in. This can be approximate. 36 degrees would again start at the positive x-axis with the initial arm. Now I know that 90 degrees would be up here because it's a right angle. So halfway would be 45 degrees, so it'd be a little less than halfway. So I'm going to say that that is my 36 degree angle. And you always need to label the angle with an arc to show which part of the angle you are talking about. So this angle ends in quadrant 1. Right, quadrant 1 right there is where it ends in. Next, let's look at 210 degrees. So 210 degrees, again, I start on the positive x-axis. And I know that this would be 180 degrees here. So I would go past the 90, I'd have to go past the 180, but I only have to go about 30 degrees past the 180. So that means the angle of 210 degrees would be something like this, and it would end in quadrant 3. Then let's look at 315 degrees. So 315 degrees would start again on my initial arm. It'd go past the 90, past the 180, past the 270 to 315, which would be right about here in the middle. And make sure that your angle goes all the way around to show that it's 315 degrees. and that's going to end in quadrant 4. All right, next we're going to talk about this important point of reference angles. So a reference angle is an acute angle. Now remember, acute means that it is less than 90 degrees. And this reference angle is located between the terminal arm and the nearest x-axis. The trig ratios of an angle in standard position are the same as the trig ratios of its reference angle, except the sign may be different. So what I mean by that, we'll just do a little example down here. What I mean by that is there's 4 different options for where a reference angle could be. A reference angle could be in quadrant 1, quadrant 2, quadrant 3, or quadrant 4. Now each one of those reference angles would have a different standard position angle that's attached to it. For example, here the standard position angle would still be 20. But here the standard position angle would actually be 160. That's because the whole straight line would be 180, but I've taken away a 20-degree chunk, so 160 degrees would be the rest of the reference angle. Here, the standard position angle would be 200 degrees. That's because, again, it's the 180 plus the extra 20. And here, the standard position angle, the reference angle is 20. Here, the standard position angle would be 340 degrees. Because again, the whole way around would be 360, but this 20 degree is the reference angle portion. So there's kind of 4 different options as to how many degrees would be included of this 20 degree reference angle. Now all these angles that I've just said, 20, 160, 200, and 340, they would share the same sine, cos, and tan values since they have the same reference angle. But we'll get more into that later. Now also, the right triangle that contains the reference angle and has one leg on the x-axis is known as the reference triangle. So each of these reference angles could be made into a 90-degree reference triangle, which is going to be very important for the trig that we do in this section. So these would be all called the reference triangles. They've got the reference angle and one leg on the x-axis. So let's move on to example 2. We're going to determine the reference angle for each one and sketch the standard position and reference angle. So here we've got a 130-degree angle. So a 130-degree angle would lie in quadrant 2. So this, let's say this is 130 degrees. That would be the standard position angle. Now the reference angle will be from that terminal arm to the nearest x-axis, so the remaining portion. I know that the straight line is 180, so that means if I already took 130 away, I'd be left with a 50-degree reference angle. So we say theta r, because that means reference angle, is 50 degrees. Let's try the next one, so 300 degrees. Now 300 degrees would be in quadrant...
Hey.
Okay, so if that is 300 degrees in quadrant 4, that leaves us with a 60-degree reference angle, since the whole way around would be 360 degrees. So we would write theta r equals 60 degrees. Our final example for today, we're determining the angle in standard position when you start with a 40-degree angle and then you reflect it in different ways. So first it says reflect about the y-axis. So that means reflect it over the y-axis. So I'm basically taking that 40 and reflecting it this way. But then I don't want to know that angle. I want to know the standard position angle. So the standard position angle would be this portion. So if I removed the 40-degree reference angle, that means I'd have 140 degrees left for the remaining part. The next question is we're going to reflect it over the x-axis. So this 40 would now be flipped upside down and it would end 40 degrees here. So now if I want to find the standard position, I would be going all the way around to that 40, which would be 360, subtract the 40 degrees to be 320 degrees. The next one is saying we're going to flip it over both the x and the y. So if I flip it both over the x and the y, the 40 degrees will end up down here in quadrant 3. Now again, I want to figure out that or the standard angle that goes all the way to quadrant 3. So this time it would be the 180 plus the extra 40, so it'd be 220 degrees to go to that point. Now I know this was a lot of new information today, so please take your time to go through these textbook questions and make sure you ask if you have any concerns. Have a great day.